Hey, Kevin here. So we're going to talk about this pill or module which comes from another manufacturer. So it took me a little while to get everything out of it. So that is the LED focusing ring. We'll lay that aside. And alright, so this is the LED board. It is on a cheap aluminum board. Not to mention they use a white, it's basically like a silicone, basically like caulk almost, that holds the LED in place. Well, heat is the killer of LEDs, and there's a lot of airspace under that. The LED transmits the heat to the PCB, which is this here, and then that transfer heat to the pill, which transfers it to the body of the flashlight. Well, as you can see, there's a lot of airspace around that wasn't even making contact here to transfer the heat. Not to mention, you see how thin that is? This is what it's going to get replaced with. This is a much better PCB. It is a direct thermal pathway. The center beam here, post here, is a solid piece of copper going all the way back to all of this. So that's the direct thermal pathway, the DTP. So this sits right up under the LED, and what it's going to do is transfer the heat directly from the LED to the bottom of this, to the pill, to the flashlight body. With this one, these are multi-layer boards. There is no direct thermal pathway. So what happens is that heat has to basically saturate through the different layers through aluminum, which is not as good of a conductor of heat as copper, and then from that bypass this crap here that they use to glue it down with to the pill. I am going to use Arctic Alumina to glue it down, which has much better heat transfer properties. If it had a retaining ring to hold the LED down, then I would use Arctic Silver, which is one of the best products on the market as far as transferring heat. Let's look at the driver. Skinny wires, which means more resistance. And not to mention, these here, 1, 2, 3, those are 7135s. 7135s are chipsets, and that helps regulate the current for the LED. Each one of these is either going to be 0.38 amps or 0.35 amps. So I'm going to assume that these are 0.35, and 3 of them would put it right at 1 amp of current going to the LED. We are going to change this out for a much better one. We can see here we got much thicker wires compared to the old one. Not to mention, these have 1, 2, 3, 4, 5, 6, 7, 8. These are 3.04 amps. So what I'm going to do, these are 0.38 a piece. And so what I'm going to do is take 3 of these off of here, and then it will be running right around 1.9 amps. Almost twice the current of this little thing here on a much better PCB. So it should be much brighter.